People in the northeastern corner of the state have been hearing what sounds like a jet airliner, looking up and seeing a light plane. What they saw and heard during its test flights early this year was the first aircraft completely designed and built in the state of West Virginia. At Morgantown's Hart Field, the plane is currently undergoing modification at the WVU hangar.
In 1968, the Department of Aerospace Engineering at Virginia University received a long-term contract with the Office of Naval Research to investigate STOL aircraft. And on the basis of several years of theoretical and experimental studies, we decided to build an actually flying aircraft, as you see here. This plane weighs 2,200 pounds, has a wing area of approximately 115 square feet, and rather interestingly, it has two engines, a conventional piston engine in the front of 180 horsepower and a jet engine of approximately 200 horsepower embedded in the fuselage, which is used to produce compressed air for the unique flap system that is used on this aircraft. We have successfully flown the aircraft at the present down to a speed of 30 miles per hour, indicated airspeed, which indicates that the plane will land in approximately less than 500 feet.
The aircraft has a specially designed wing which looks the same as most other wings because it has a sharp trailing edge which is necessary for high speed and low drag performance. However, when you want to land or take off, we need increased lift above the wing, and we obtain that by folding out the flap. This flap now provides a greater area for lift distribution, and a unique jet engine which is built in the back provides compressed air through this arm and into this rounded trailing edge, and then the compressed air comes out of a slot and blows in this manner. Now, the effect of this blowing air is that it pulls the air from above the wing at greater velocity, thereby generating more lift and allowing this aircraft to fly at much reduced speeds. Besides the rounded trailing edge, another unique feature of this flap is that it can fold totally forward and be embedded in the wing in this space provided for it. This is done, of course, after the aircraft has climbed to a safe altitude.
Dr. Vannucci, it's a little unusual for a university to build an entire airplane, isn't it?
Yes, I believe it is. I know of one other university that has attempted something like this, but it is somewhat unique to go all the way from wind tunnel experiments in the laboratory to an actual flying aircraft.
Who actually did the work on this plane?
We have three excellent aircraft mechanics in our department. We're quite fortunate. I believe this aircraft mechanic team is probably one of the best in the state, and this is one of the reasons we decided to go ahead with the project.
Did you have students working on this?
Yes, we had many master's and doctoral students who did their master's and doctoral dissertations on this aircraft, and of course we had 3 or 4 other professors working on various phases of this project.
Dr. Loth, there are a lot of planes that use this technique of blowing air over the wing. What's so unique about this?
This is true. Several aircraft, experimental mainly by NASA and Boeing, have used blowing over the wingspan, but they use a different method of blowing actually over a surface with a sharp trailing edge, like the blown flap or the augmented wing. And this system blows over a rounded trailing edge, and it is more efficient. It takes less horsepower to get the same lift.
Most STOL aircraft land at very large angles, which is rather uncomfortable for the pilot because he can't see over the nose. This aircraft lands practically level, and that's very unique and very desirous for pilots. I envision this plane to be, or this method of high lift to be used on aircraft for short-haul operations. That means commercial passenger-carrying aircraft operating out of small fields near large cities, or a military application possibly would be for aircraft carrier operations, where slow speed is of paramount importance.
Dr. Finucci, you think there are ever going to be airports specifically designed for short takeoff and landing planes?
I believe so. I saw a very interesting design whereby the airport was not in the constructed in the conventional sense, but was completely round like a platter. And if a STOL aircraft can land in a short distance, then it can land independent of the wind direction, and this is rather unique. The other advantage of STOL airports and STOL aircraft is that their dwell time over populated areas is less, because their approach angles are much steeper to landing, and conversely their takeoff angles are much larger, so that they can remove themselves from populated areas rather quickly and cut down noise pollution.
Do you think that these airports could be tucked into the hollows of West Virginia?
I don't see why not. I believe short runways are of paramount importance to a state like this that has such a scarcity of flat land.
Was this in your mind when you started designing this plane?
Honestly, I must say no. We were more interested in the theoretical aspects of high-lift wings, and as most engineers are when they're in the beginning of any research project, and usually the applications follow after discovery is made. And one can always think of uses for something after it's discovered. There's a history on this sort of thing.